Hi there, welcome to my channel Mandu to Fundu. In this video, I am going to discuss about the solution for finding the researcher's H index problem. Let's look at the problem description. We are given an array of integer citations where the citations of I is the number of citations a researcher received for their ith paper. We have to return the researcher's H index. Let's see what is H index. So it is defined as the maximum value of H such that the given researcher has published at least H papers and those papers have been cited at least H times. Let's take a look at the example 1. So the citations array is 30615. If we look at it, 3 and 6 and 5, these three papers have received citation for at least 3 times. 3, so we have to return 3 as the H index. So in this case, 2 papers received the citation at least once. So the output is 1. And the length of the citation array is ranging from 1 to 5000. So there is at least one element in that input array. And then the citation value is ranging from 0 to 1000. Let's look at the approach to solve this problem. So we have this input array and the expected output is 3. Okay. So the first approach is a brute force approach. In this approach, we traverse this input array as many times as the number of elements present in the input array. Okay. So in each iteration, for example, iteration 0, we pick up number 3 and then compare all other elements and count how many elements are greater than or equal to this value. So in this case, 1, 2 and 3. We keep track of this value. So the next iteration 0. So in this case we skip that iteration, and the third one is 6. So we check how many elements are greater than or equal to 6. There is only 1. Then 1. We check how many elements are greater than or equal to 1. So we keep track of whichever is the maximum and that is equal to the number of citations. Then we will return that. So in this approach, we have to do n times n processing of each element, total number of elements. So it will be order of n square. Second approach is a transform and conquer approach. So in this case, first we sort this input array in a descending order. So the highest value will be in the first element all the way to the lowest. Okay. Then we maintain a variable that counts the number of papers we have published so far as we traverse, and then we maintain the H index, which is the current index value. Okay, so as we go down, the value will be decreasing. On each iteration, we check whether the citation is less than H index. In that case, we updated the H index to that new value, and then we check whether the H index is greater than or equal to the max citation computed so far. If it is greater than or equal to, then we found the H index value and we return. Otherwise, we simply increment the max citation count and proceed with the next index. So we keep traversing, and we will at the end we will either we find the H index at the end or early on. Let's look at the flowchart. Input for this procedure is a citation array. First we sort the citation array in a decreasing order. Then we initialize the count variable and then H index to the first element of the citations array and the max citations to 0, and then the index will be initialized to 1. Then we check whether the H index is not equal to 0, the first element is not equal to 0. Then in that case we set the max citation value to 1. Otherwise we proceed and enter the for loop. So we check whether we processed all the elements in the array. If not, we go and check whether the current element is equal to 0. In that case, we will return. Basically, since the array is in a decreasing order, for all other elements following are zeros. Anyway, we will be ignoring the zeros citation. So we simply return from this function. Otherwise, we check whether the current citation value pointed by the index is less than the current h index. Next, we check whether the citation of index is less than the current value of h index. In that case, we will have to update the h index with the citations of idx. Otherwise, we will check whether the max citation is greater than or equal to h index. If so, that means we found the h index, so we will return from this function. Otherwise, we increment the max citation count and then proceed to the next iteration. So once all the elements are processed, we come out of the loop and we return the max citation back to the caller. Let's move on to coding. First, I sort the input array in a descending order. Next, I initialize the count variable with the number of elements in the input array, and then the h index value with the value of first element in the array, and then the max citation is initialized with 0. Then I check whether the h index is not equal to 0. Then in that case I have to initialize with the value 1. This is to handle the case where we have the single element array with value 0 in it. Next I write the for loop, and here we process the element starting from index 1, and first we check whether the current element is 0. If so, break out of the loop. Next I check whether the current element is less than the h index. In that case, update the h index with the current element. Then I check if the max citation is greater than or equal to h index. In that case, we found the h index value. We return the max citation as the h index value. Otherwise, we increment the max citation count and proceed with the next iteration. After the loop is done, then we return the max citation. Next, I am going to run the test cases. Oops, there is some compilation error. Oh, I missed the if. Another one. Okay, all the tests passed. Next, I am going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. So we have the input array 30615 and the expected output is 3. Okay, so let's see how the output 3 is generated. First we sort the input array in the decreasing order. So this is before transforming the array. This is the after sorting the array in a decreasing order. Okay, and then we initialize the count variable to number of elements in the input array, and the h index value variable is initialized with the h index variable is initialized with the first element in the array, and the max citation variable is initialized with 0. Okay, and then we check whether the h index is non-zero value. If so, we initialize the max citation variable to 1. So this is to take care of edge cases like single element array with the value 0 and with the value non-zero. Those kind of cases are handled in this check. And then we enter the for loop. We start processing from index 1. So when we enter the loop, the h index is initialized with 6 and the max citation variable is initialized with the value 1. Okay, so inside the loop, first we check whether the current element is 0. In this case it is non-zero, so the else part is executed. We check whether the current value is less than the h index. Yes, it is. So 5 is less than 6, so we updated the h index with the current value pointed by the idx. So the h index becomes 5. And then we check whether the max citation is greater than or equal to h index. In this case it is not. So we simply increment the max citation count and then go and process the next element. So the max citation variable become 2. The iteration 2, when we enter, the h index is 5, max citation is 2, and the idx is pointing to the third element. Okay, we check whether it is a 0. It is not. And if it is less than the current h index value, yes it is, then we immediately assign this value to the h index. So h index becomes 3. And then we check whether the current max citation value is greater than or equal to current h index. It is not. So we simply increment the max citation variable, so which becomes 3. The next iteration, when we enter, the h index is the 3 and max citation is 3, and the current idx is pointing the fourth element, which is 1. So we check whether it is 0. It is not. And then whether it is less than the current h index. Yes it is. So we updated the h index with that value 1. And then we check whether the max citation value is greater than the current h index. Yes it is. So 3 is greater than 1. So we simply return the max citation value. So that is the expected output. Next I am going to do the time and space complexity analysis for this solution. Okay, let's do the time complexity analysis for this input. So in this procedure, first we do is sort the input array. So that complexity is order of n log n. And after that, as per that the code flow diagrams, this entire for loop runs 3 iteration. So instead of all the processing the rest of the 4 elements, on the third iteration itself we are able to find the h index. So but that is in terms of the number of elements in the array. So we can say that for this for loop the time complexity is order of n. For thus the sorting is order of n log n. So when we add both of them, we take the dominant term. So this n log n is a dominant compared to the order of n. So time complexity of this solution is order of n log n. And with respect to the space complexity, it is order of 1 because we are not allocating any additional space. We use only variables. So the space complexity is order of 1. Thanks for watching this video. Have a great day.